So if you don't have the question, you cannot build anything. So define the question is the first step, and then we have to build everything.
So do you mean that based on the digital twins, since you were saying that connection between business teams and data teams are very important, do you think that the digital twins could be something like an emblematic tools to make both sides discuss all together?
Yeah, it's the idea. That's why it's difficult. Because you have to make people discuss all together, and sometimes they have not the same vocabularies, they have not the same objectives, they are not talking about the same thing. So yeah, digital twin is something that can be very complex if you think about a very large scope for the application.
So it's a good way to go forward between both teams. Antoine, maybe also to discuss other kind of use case. You have so many use cases at EIT. I think you have 14 or something like that, just when we prepared the conference. But there's one which is very interesting and very current also, which is decarbonization, also raw materials. And you have one of the projects which is on zero defect manufacturing. Could you tell us a little more about that one, and also how you can manage to reduce defect in manufacturing?
Yeah, actually a little bit of correction. Just let's say that the topics relating AI right now in one workshop. We have a lot of projects also revolving around other topics. Gaia X is also included with us, so we're also part of that with the Europagigant project. So Germany and Austria have the communication the same as Gaia X in itself. So I know that one. For, let's say, raw materials and zero defect manufacturing. Let's say about that. When we're talking about zero defect manufacturing, everybody says, oh yeah, that's a dream, actually. Yeah, so that's everybody who's going into production who wants to do is, okay, I produce one part and this is the one part that fits my need perfectly. But this will never happen. Yeah? So the machines are still influenced by outside parameters, by inside parameters, by fluctuations in the material and so on. So the first thing is you need to inspect everything. For now you have statistic models. For most of the materials you get, you have, let's say, an approach that you have statistically that much material included, or the material composition is just a composition in definite percentages with an enhanced inspection. You could check out for all this data what you have, but then you get more and more data, and then you have to step into AI, because you don't have the working power or the resources and work to check all this data, to get back into, let's say, okay, is this material the right one to use for this part? Maybe not. So you're looking for the next batch of materials to get used. So first, from my perspective, is checking up the materials, checking up what you're going to use it for. Is it maybe the right thing for it? A little bit like a woodworker, yeah? If you're going to make some furniture out of a dedicated part of the wood, you're choosing the wood because if you have something like failures included in it, it's not going to hold, or it's not going to be easy to work around it. And I think that's the same what's going on for manufacturing. So in manufacturing, we have to start inspecting and really put into an eye in that. But then we get into a problem, because as the models are running on, because we have to collect data, we have to find out what are the real important data topics we have, or the key factors we can take out of it for production. But then after some time, you have the aging of your model, your emerging ages. So you have to again enhance your model. You have to have a self-learning model building on top of the existing one. And that should then include everything that was changed, every parameter that was changed, maybe even human collaboration that's going into it, because if the human tries to change this one part in the machine, and the machine is not aware of that because the sensor is not taking that into account, that a new tool was added or something like that, then you're just starting anew with your model, and you're just not going to be able to produce really what you wanted to do.
Okay, thanks a lot, Adrian. Maybe Michel also, we can discuss some also very interesting case. You have merging both teams, data teams and business teams. Could you tell us how you simplify also deployment of AI use case with the different teams?
Yes, maybe what I can share with you. Yes, I have some picture with me. So yes, as I said before, one of my passion is to find ways to really bring data science in the hands of the end user. And so what we do at TotalEnergies is that, so of course we build a lot of web application with machine learning inside, but sometimes we also find really we search ways to deploy really machine learning and data science in the devices that are used on the field by the user. And this is, so I have two use cases on that I would like to share with you. So yes, this is a typical example on that. What we had to do is I don't know if you see on the picture, but we have some character on the pipe. So this is a pipe that is used in some industrial facilities. And what we wanted to do is to have a character recognition on the character written on the pipe. Unfortunately, the way it is written is so bad that we cannot use off-the-shelf models to do the optical character recognition. So we build our own deep learning model to do that. And what is really cool is that then the models were already deployed on the smartphone that are used by the engineer on the field. And so we use the camera of the smartphone to call the model and to do the character recognition. And yeah, this is an example of already on the field it is used. And as an old data scientist who knew the old times where it was so difficult to deploy model into production, I find we are really living in exciting times where we can easily deploy model in smartphone and in this kind of devices. So this is really, really cool. And maybe the other example I would like to share with you. So this is something that we did for, you may know that TotalEnergies has an affiliate which is called SAFT. And SAFT is doing professional, so it's doing batteries for industry. And here we work on this use case. The objective was to improve the quality processes of the battery production. And we built a machine learning model that gives some probability of non-quality. And what we did is that once we build the model, we really deploy it on the field. And what you can see on the picture in the top is this is the quality engineer, which is using a multimeter. And once the multimeter takes a measurement, it writes the measurement into the database. And when we do this writing, we call the machine learning model, which gives the probability of non-quality of quality. And then we, in real time, display this level of risk really in the shop floor, and so that the quality engineer can take his decision about what to do with this battery, really when he takes the measurement with the multimeter. And so this is really, yes, really on the field ways of deploying model, and this is really something that I like to do with my teams.
And just a tech question, your models are embedded in the smartphones or in the multimeter or close to the multimeter, or do they call some APIs? For
the smartphone, it is embedded on the smartphone.
Okay.
Which means you have to optimize the computation, because yes, we are not. Yes, it's not a supercomputer, so we need to.
It's not an HPC, so.
On this case, it's a little bit different. The multimeter only take the measurement and then write it in the database, and then we call the model only when we have an information in the database, and then the model is in the cloud. So it's a different.
Which kind of SLA? How much time to call and have the feedback of the model?
In this case, it's almost
real time.
Yes. So
below 1 second. So
yes, or 1 second, something like that. But it's quite yes.
So thanks a lot, Michel. But Renaud, maybe we can talk. My question was not free, but maybe we can talk also about embedded AI and how embedded AI could be interesting for industry as well.
Well, the state sponsors the embedded AI way. It's a substantial part of our national strategy because we think it has two main implications. The first one is that embedded AI, cyber-physical systems, digital twins, will make the shop floor, the work of the factory much more adaptable and much more also inclusive for in the era of cobotics. And AI is now trying to solve the Moravec paradox, which states that the most complicated things are easy for computers, but not the easiest things for humans, which is seeing, interacting, moving, and now prehending. And now there have been lots of progress in the past few years, thanks to machine learning in part. And we think that this will change a lot the factory workflow, and we need to accelerate on that. And of course, we need to carefully also weigh where we will put AI, where we put connected objects, because obviously we need also to conduct an ecological transition. And this is where we should also try to avoid as much as possible to move data to the cloud which are not necessary. So we think also that embedded AI has two qualities. First, there are constraints that stimulate imaginations, engineering talents, and in order to diminish the size of the models and to use only the right sensors that are, and not to go with the maximum difficulty, the heaviest deep learning for nothing. And the second time also, it would help create a more frugal way with predictive maintenance, with the minimization of inputs and outputs. And that's why we support it, and that's why also I would say a great part of the research program funded by the state will devote on these issues.
Thanks a lot, Renaud. So I'm really sorry because Heikki could not be connected. I just want to, by the way, this is the first slide of Heikki, which is the hybridization of physical model and also learning models. And the use case, which is also, I would just give you some insight because it's not my slide, so it's not such easy to comment, but I think it's really very interesting also for industry. It's how VTT also create models to discover new materials. So there are many use cases actually in the AI sector to use whether this kind of model. So this one is based on the graph neural network or GNN. So to enter in the physical matter of the material to discover where you have some disconnection and potentially also to create new molecules. And there are also in France, you have this kind of models which are developed at Janzé with large AI models, especially to find new molecules in the chemical sectors. In Germany, you have also the large European AI models which are developed and which are also used to discover what all the knowledge which could be in different patterns, and also to create potential new molecules to mix data from large AI models, but also with data which could come from spectrometry, and then AI will have a much larger data sets to discover potential new molecules. Maybe Michel, something which is quite close at what you did, maybe with Google on NLP to discover new information on the.
To be honest, this is too complicated to me. We didn't do that with my team, but this is more for the R&D team, which is just over there.
It's an R&D project from Finnish Center of AI. Yes.
If you want to meet TotalEnergies R&D, they are just over there on the corner. So feel free. No, what we did. Sorry, with Google was more information retrieval from complex documents. So we have a huge legacy of geoscience document with the text, picture, different kind of graph and so on. And what we did with Google was a 3-year project to really improve the information retrieval in this historical information.
Maybe I don't know if there are some questions in the room. No question. So I have my magic question. I was very surprised when we prepared the conference. Yes, it's a question which is not in the roundtable. But because of course trust in AI, especially in the industry side, is quite important. And I was surprised that nobody talks about trustworthy in AI. So is it something that you don't consider? Is it something that you manage on another way? Maybe Renaud, if you want to start, because there is a big topic also on trustworthy, but.
Maybe it's because there are too many events talking about trustworthy AI in a very general way, and we are there's some fatigue about it. But yes, we are in the process of drafting a very important regulation in Europe, and the French presidency of the EU has, and we spent a lot of time. Hopefully, some part of the industry will be spared from the high-risk definition, so which will alleviate the burden. But to be serious, it is true that. Ensuring the safety, the question of trust is on many dimensions, but there's a question of safety, for instance, in transportation or in health, or also it's a question of equality before biases, and biases can lead to discrimination in banking, in housing, in education, recruitment, in AI, human resources management. So we need to be able to develop new engineering methods. And it's not easy with statistical AI. That's why we need to and the experts need to redraft, revise, and to make new engineering methods, new confidence intervals, new integration system, new human-in-the-loops control mechanisms. And these are the things that are at the core of the AI regulation. And hopefully it will be only a general horizontal, which help everybody to have a strategic view, but it will give a lot of importance to standardization and sectoral regulation in order not to be to constrain too much this sector, and to be able to suit on a fashion way, like a suit that is tailored to the thing.
Maybe Emmanuelle, yes, Michel, yes, if you like.
Yes, I didn't tell you anything about that because you didn't ask me the question, but if you ask me the question, I'm very happy to to answer. So on my side, what we try to do is to have a very practical approach of the topic, because otherwise it's quite easy to have some high-level idea, but not to do something very concrete on that. What we have done, especially with my team, so from the Digital Factory, is that at the end of the last year we conducted an audit with an external third party that use a trustworthy AI framework and that evaluates the different risks that we can have on what we are doing. And now, based on that audit, we are working on a roadmap to really improve our practices, which are quite specific because, as you say, as you may have seen, you are working a lot of industrial topic. So we have a lot of question about keeping human in the loop when we deploy models into the shop floor, how to make augmented decision when we are working on critical systems, because we are operating a lot of critical systems, so we really need to know what we are doing. And so now we have this roadmap. And for all the priorities on this roadmap, we are having a very concrete approach on that. So we are trying to develop some tools, some practices with the data scientists so that they can really, it's very concrete and it's not just some assumption, but we are trying to develop tools. And so that we also onboard the data scientists and the people with us because they know why we're asking that. So that's the way we are approaching these topics with my team.
So do you mean also that you have different level of trustworthy depending on the use case and of course of the usage?
Yeah, exactly. Yeah, different level, but it's also so I won't deep dive on all the topic, but you have the question of human in the loop, operating on safety system. We have also what you mentioned before about using the right level of computing power, because sometimes it's not the best idea to use a big cloud or to use a supercomputer.
Need to overfit the model.
Exactly, and so we have a lot of topic on that.
Emmanuelle, maybe you would like to talk about human in the loop and how you can have the human in the loop with the training, with the AI and data teams.
We have the human user. No, it was more about there are the question of the trust in AI, in the fact that the results you give, can I be confident in it? But there are also the question of the formation of people working in the industry to AI, and to work with AI, to work with digital twin, to work with robotic, where sometimes you have some AI inside. So there are also the trust of people working in the industry with this new technology to work with and to be confident and to be able to work with this thing. So it's not exactly the same thing, but I think it's something very important because sometimes you need to think about this before deploying AI in industry.
Yeah, but
just a small.
I agree. That's why also it's very important for us. As I said in your first question, that's why we are involving the end user. Yes, very early, and we are building the solution with them so that they know exactly what is inside the models, and so this is a key, and we did that on all our projects indeed.
Yeah, from my perspective, that's the right procedure to do that. But how do you decide if a failure occurs while using AI? Who's the one responsible for it? Is it the human or is it the AI responsible, or is it the developer responsible for that? And I think that's a question we have to clarify before even going into is it trustworthy or not.
Agree, yeah.
A whole chain of responsibility. This is a whole chain, and responsibility will be shared, and we'll have to go case by case. It will not be the same where AI propose a recommendation, then the human will be clearly responsible. If it's a fully automatized system, then the developer and provider will be responsible. And maybe when you have a system that that is AI automated based on and which can affect negatively people, then we may never be able to say that an unfavorable decision will be able to be taken by an AI. Only the positive ones will be decided by an AI. There's a whole range of possibilities.
Okay, so thank you very much for all the insights you shared. To all of you, thank you also to attend this session. I hope that you get some insight and that you can put AI in your different industry as well, with low-hanging fruit that even on the methods, and also to combine human and AI and training classical teams with AI. Thanks a lot.
Thank you very much.
Thank you, Antoine.